Imagine drifting off to sleep when, still with your eyes closed, you've suddenly startled by an intense flash of light. This is exactly what some astronauts have reported when passing through the South Atlantic Anomaly, SAA, a region of the Earth's magnetic field, also known as the Bermuda Triangle of space. When the International Space Station passes through this area, computers can stop working and astronauts experience cosmic flashes. There is an area of the North Atlantic Ocean known as the Bermuda Triangle where ships, airplanes, and people have been known to disappear without explanation. No one knows for certain why more than 50 ships and 20 planes have vanished since the mid-19th century. But that's not to say that people hadn't had some fun seeking an explanation. Maybe it's to do with extraterrestrials, a force pulling objects under the sea, or a link to the fabled lost city of Atlantis. Or perhaps it's simply bad weather, human error, or heavy traffic in the region. In truth, the number of disappearances are actually no more than any other well-traveled area of the ocean. Yet, still, the conspiracy theories persist. If we look skyward, we can explore a similar phenomenon dubbed the Bermuda Triangle of space, a vast region above Earth that has been known to wreak havoc on spacecraft that happen to enter that area. In this case, nobody is claiming that craft are suddenly vanishing into thin air, but the disruption that's being caused is nevertheless serious, and it does pose great problems for both equipment as well as astronauts. The Bermuda Triangle of space, or the South Atlantic Anomaly (SAA) as it is formally known as, lies above the South Atlantic, stretching from Chile to Zimbabwe. It sits at the point where the inner Van Allen radiation belt comes closest to the Earth's surface. Here, the magnetic field of the Earth is particularly weak. To explain, the Earth has two Van Allen belts, a couple of donut-shaped rings of charged particles that surround our planet, held in place by the Earth's magnetic field. The inner part consists mainly of high-energy protons, and the outer part is mainly electrons. Because the belts trap the particles that are shooting from the surface of the Sun, they end up protecting the surface of the planet from harmful radiation. At the location of the SAA, however, the particles of cosmic solar rays are not being held back to the same extent as they are otherwise aware the planet. As a result, solar rays come as close as 124 miles to the Earth's surface, and the more intense solar radiation results in an increased flux of energetic particles in this area. Ordinarily, the Van Allen belts stretch at an altitude of between 1,000 and 60,000 kilometers above the Earth's surface. The low altitude of the radiation hotspot, however, puts it within the orbit of certain satellites, which become bombarded by protons that exceed energies of 10 million electron volts at the rate of 3,000 hits per square centimeters per second. As experts have pointed out, this affects the spacecraft's onboard electronic systems, which hampers the operation of these objects. To protect them from potential hardware damage, space agencies and other satellite operators power them down so that the anomaly does not end up knocking out onboard computers and interfere with data collection. Shutdowns protect many important studies, including those using the Hubble Space Telescope, which passes through the SAA 10 times a day, spending a good 15% of its time there. Hubble is unable to collect astronomical data during these moments, which is not ideal but necessary. Failing to take precautions would likely lead to system failure. Indeed, the SAA is why strong shielding is in place over the most frequently occupied parts of the International Space Station, such as the gallery and the sleeping quarters, reducing the amount of radiation that the astronauts are exposed to. It is also why astronauts wear dosimeters, which are devices that measure their personal exposure to ionizing radiation in real time, that sends out a warning if they reach dangerous levels. To sum up then, our magnetic field is not perfectly aligned to the rotation axis of the Earth, which means that the Van Allen belts are tilted. This leads to an area 200 kilometers above the South Atlantic where these radiation belts come closest to the Earth's surface. Meanwhile, the Hubble Space Telescope is unable to take further observation. Further study of the SAA will be crucial for the futures of commercial space travel. Thanks for watching till the end. If you liked this video and learned something new from it, please leave a like and definitely go subscribe to our channel